Assalamualaikum warahmatullahi wabarakatuh. Now we will move to the last applications of redox reactions, which is transfer of electrons at a distance, which also known as U-tube. The aim of the experiment in U-tube is to determine the transfer of electron at a distance. A reducing and oxidizing agent are separated by an electrolyte in a U-tube. The transfer of electrons occur through the connecting wires and can be detected by a galvanometer deflections. Look at this diagram. The U-tube is filled with electrolyte, which is dilute sulfuric acid. The function of the electrolyte is to allow the movement of ions through it. Both arms of the U-tube are filled with substance that release electrons, which is a reducing agent. On the other arms, the U-tube is filled with substance that receive electrons, which is oxidizing agent. Carbon electrode that immerse into the reducing agent is the negative terminals, while the carbon electrodes that are immersed in the substance that receive electron is the positive terminals. Electrons will be transferred from the reducing agent to the oxidizing agent through connecting wires. We can see the changes in the color of the reducing agent and oxidizing agent. To confirm that there are transfer of electrons, the galvanometer needle will be deflected. Let us discuss about the transfer of electrons in a U-tube by using some example. Let's say a reducing agent used is iron 2 sulfate solution. We know that iron 2 sulfate solution, the color is pale green. On the other arms are filled with oxidizing agent, which is chlorine molecule. We have learned in displacement of halogens that chlorine, which is situated on the top of the halogen series, are a stronger oxidizing agent and has higher ability to receive electrons. The color of chlorine water is pale yellow or almost colorless. During these reactions, the substance that will release electrons is iron 2 ions. The electrons will transfer from iron 2 sulfate solution to chlorine water through external circuit. Look at what happens. Iron 2 ion release electrons to form iron 3 ions. Iron 3 ions have different color from the iron 2 ions. When the electron transfer to the chlorine molecule or chlorine water will receive the electron and produce chloride ion. We can see the change in color of a reducing agent from pale green to brown, while the chlorine water will change its color from pale yellow or light yellow to colorless, because the color of chloride ions is colorless. Now, how do we know which substance are able to become a reducing agent or oxidizing agent? We have learned before the three example or application of redox reactions. We have seen that metals atoms have higher ability to release electrons. Iron 2 ions will release electrons, and the lower position halide ion also has higher ability to release electrons. This will make these substances a good reducing agent. So, the carbon electrode that are immersed into one of these reducing agents will become negative terminals. On the other hand, we also have learned that iron 3 ions are able to receive electrons and form iron 2 ions. The top position halogens also have higher ability to receive electrons, such as chlorine and bromine. The new oxidizing agent that are able to receive electrons are acidified potassium manganate solution and acidified potassium dichromate 6 solution. This oxidizing agent, we have been using it during the carbon compound topic earlier in this year. Now, let us see another example of a transfer of electrons at a distance using U-tube apparatus. In the left arm, the substance that been added is iron 2 sulfate solution. We can see that the color of the solutions is pale green. It shows that this solution is iron 2 sulfate solution. On the other arms, the U-tube is filled with acidified potassium manganate 7. Acidified potassium manganate 7 is purple in color. Because acidified potassium manganate solution is an oxidizing agent that are able to receive electrons, the carbon electrode immersed into the acidified potassium manganate 7 will become positive terminals, while the carbon electrode that is immersed into the iron 2 sulfate solution, which is a reducing agent, will become the negative terminals. So we know that the electron flow will be from negative terminals to the positive terminals. Let us see what happens during these reactions. Iron 2 ion will release electrons to form iron 3 ions. Again, we know that iron 3 ions are brown in color. In these reactions, iron 2 ions undergoes oxidation Therefore, iron 2 ion is a reducing agent. Now look at the changes in the color of the solution on the left arm. The color changed from green to brown. It shows the presence of iron 3 ion. In order to confirm the presence of iron 3 ions, we can always use sodium hydroxide solution. Next, on the right arms, manganate ion and hydrogen ion comes from the acid will receive electrons and produce manganese ion and water. These receive of electrons ensure that manganate and hydrogen ions undergoes reduction reaction. Therefore, acidified potassium manganate solution is an oxidizing agent. The color changes for the acidified potassium manganate is purple changed to colorless, because the oxidation number of manganese changed from +7 to +2.